Good morning, everybody. So, today we have a math day, and like I've been telling you, this is really the brain of the class. If the heart of the class is the scientific process, the the process of through pattern analysis, identifying a question, coming up with a solution, analyzing that solution, and then reconfiguring it and trying to make that solution better is the heart of the class. To me, this is the brain of the class. The idea of how to solve math problems, not from a mathematical standpoint, not from an algebra standpoint. I'm not too interested in your ability to move stuff around in an equation or that kind of stuff. When I talk about the steps to solving a math question, I'm really talking once again about a mindset. So just like with our labs, with the experimental process, the experimental design, engineering design, scientific design process, whatever you want to call it, I developed my own mathematical thought process. And the goal of this was ultimately the same as the idea of the scientific mindset. The point to me was to come to a place where I could approach every math question I was given in the same way. And like I've been telling you on a daily basis, you can't be good at something unless you're able to repeat the process by which you approach that particular thing. So unless you repeat it and using the same process, the same steps over and over and over again, you'll never become good at it. So this is what I ended up having to do in order to start to successfully solve math questions. So I was terrible at math, not because I didn't understand how to move one variable from one side of the equation to the other side of the equation. I mean, that's what you're being taught how to do in math class, being taught how to mechanically manipulate an equation or something like that for the most part. I was terrible at math because I could never even get an equation. I could never get to the point where I had an equation written on the paper for me to solve. I'd read a math question and I'd have no clue what's going on. So, over much trial and error, I came to the process of creating a series of steps that I found worked almost all the time, regardless of the math question I was given. So, when we do math in this class, this is what I look for. So, as I've told you before, I'm not grading your final answer really, but I'm grading the process that you go through in coming to that final answer. So, that's what we're going to work with today. And that was your homework from last class. I asked you to preview what we were looking at today. So we're going to start our warm up by just going over the flipped homework. So we're just going to do a quick review on that. So again, we can click over to the warm up and we're going to review there. Then you're going to get the rest of class today to practice. So this is your homework. So again, I always assume that nobody does the homework. So even though we should, I assume that we don't. And because of that, especially with something as important as this, we're going to take some class time to go ahead and do that. So looks like my screen locked up there, but you'll find the actual same as everything here because it's something I want turned in. You'll find the assignment here. We go over to Teams. You'll find it in the Teams folder itself here. So this is where we'll find this. So it looks like that's not coming up either. Oh, so this came up here. So I've got a couple. We're going to practice the math steps using a very simple equation. So we're going to be using the density equation here. So I have very simple density problems here. Again, the purpose of this isn't to teach you how to or to evaluate whether you can calculate a density problem correctly. It's to give you an introductory level of math that we can use to focus really more on the steps that we go through rather than the final answer stuff. If you need a refresher on what density is, here are a couple of videos on what density is. Then over the next couple of days, we're going to be doing some density actual hands-on labs as well. So like I said, I also assume not just that nobody does homework, but I also assume that, like me, the vast majority of us don't learn anything by doing a worksheet like this. It's not hands on, it's not tied to anything concrete. It's just disembodied math problems, which is why no one ever really learns much of anything doing this kind of stuff. It's just not the way we learn. But there's where we'll find, so you'll find the steps and this. So again, we're going to start today to warm up with our review of the steps and review the homework that I asked you to do. Then our exit ticket is you're going to have some time to complete the proportionality lab from last class. So I know some people still didn't do the measurements and didn't at least finish. And even if you finish the measurements, we're not finished with the calculations and stuff to put into the lab report. So we'll have some time for that. You do have homework tonight. So in preparation for our lab tomorrow, this is just homework on how to take measurements. So I have, like everything, this is more of a technical subject. So I've created a set of scaffolded notes for you. So those are located here, and it has some practice questions on. And then this is me using the scaffolded notes. So it's my lecture over this, using the scaffolded notes to answer questions on what are called measurement significant figures and uncertainties. So we talked a bit about uncertainties during our last class, where uncertainty simply means that inherent in every measurement we take, at some point during that measurement, right at the end, we have to take a guess as to what the last digit in the measurement is going to be. And that doesn't matter how sophisticated our equipment is. Eventually, we reach the end of that equipment's ability to accurately give us a number. So we have to take a guess, and that's all that's meant with uncertainty. So this is my lecture. Here's some third-party lectures over here. We got Bill Nye and some other stuff talking about significant figures and uncertainties and stuff. Significant figures deals with uncertainties. So if you've ever wondered, when you look at a calculator, how do I know how many digits to put down in my answer? That's what significant figures are. A set of rules that tell the scientist or the mathematician how many digits from that answer to actually log down. So that's what this is about. And then here again, I got the scaffolded notes that are used in the lecture, plus some practice questions for you to do. So that's what we're up to today.